many double bonds, with unsaturated just being one double bond. So you're going to take 3 different fatty acids and you're going to attach them at each of these OHs. So you're going to form an ester link at each of those. So the actual fatty acid, 2 not a 3. Now they could be all the same as each other, they could be different from each other. I've just labelled them R1, R2, R3. And we have 3 ester linkages. So we have those 3 ester links, 1, 2 and 3. And so this is why the fats and oils comes up in our ester chemistry, because those biological molecules, they have these ester links in them. And so some of the chemistry you just looked at now, if you go back a page, applies to fats and oils. Now, when we talk about fats and oils, fats, we're normally talking about animal products. They're normally solid or very close to solid at room temperature. So they tend to have very long, they don't have much branching in the chains typically, and they're often saturated. And so with the long straight chains, they can pack close together, you get strong intermolecular forces, and so they have those higher melting points. Oils, they usually come from plants. So your vegetable oil, olive oil, they've often got branched, or they've often got double bonds in there. And either of those two things make it more difficult for the chains to pack as close together. And so we've got weaker van der Waals forces between the chains, and they've got the lower melting points. So your vegetable oil, your olive oil, your rapeseed oil, your sunflower oil, they're all nice and runny. They've got weaker intermolecular forces, and they're generally healthier. But butter and lard, they've got